Students, welcome to my YouTube channel. In this video lecture, we are going to continue solving the next 10 questions from Descent chapter in Keith Williams' 10 math book. So let's begin with question number 81. If there is a 27 knot decrease in headwind, by what amount must the rate of descent be changed in order to maintain a glide slope? Okay, so they are talking about a decrease in headwind. Decrease in headwind is nothing but increase is like increase in tailwind. Okay, so whenever there is an in headwind component increase in headwind component, what happens? What is the problem? The rate of descent increases. Rate of descent increases. Okay, whenever there is a decrease in headwind, happens decrease in headwind component, the rate of descent decreases. Rate of descent decreases. So increase in headwind component, the rate of descent increases excessively more than required, and in case of decrease in headwind or reduction in headwind component, the rate of descent decreases, okay, again excessively, less than what is required. So let's say this is your runway here, okay, this is your 3-degree glide path, okay. You are expected to maintain and follow this glide path down to the runway, right? So this is your aircraft. Initially position 1, it is correctly established on the glide slope, okay, and it is getting a particular 10 knot, let's say 20 knot headwind, 20 knots of headwind. Now when this headwind component increases, when it increases from 20 knot to a new headwind of 30 knot, let's say over here 30 knot headwind, what will happen? This aircraft, the rate of descent of this aircraft will increase. So instead of being positioned correctly on the glide slope, this aircraft will find itself somewhere below the glide slope because its rate of descent has increased. So it will descend towards the ground at a much faster rate. Okay, so this will be its motion, direction of movement below the glide slope. Now let's say position number 3, the headwind component reduces. It reduces from 20 knots to a new value of 10 knots. Okay, it reduces. What happens when the headwind component decreases? The rate of descent of this aircraft will slow down. It will decrease. So instead of being correctly established on the glide slope, aircraft will remain suspended in the atmosphere for a much longer time. Okay, so it will refuse to come down. In simple words, it will find itself somewhere above the glide slope, somewhere above the glide slope, somewhere above the glide slope. Okay, so what is the solution? When the rate of descent increases in a headwind, in an increase in headwind scenario, the pilot must add power and slow down or decrease his rate of descent. Okay, in tailwind conditions or reduction in headwind conditions, when the rate of descent decreases, the pilot will have to cut his engine power, okay, and deliberately increase his rate of descent. Now in this condition we are experiencing a tailwind condition. Okay, so the rate of descent, the change in the rate of descent required will be equal to 5 into change in the ground speed of your aircraft. Okay, so 5 multiplied by. Now, whenever there is decrease in headwind, when headwind component decreases, what will happen to your ground speed? The ground speed will increase. So, if headwind decreases by 27 knots, your ground speed of your aircraft will increase by another 27 knots. Okay, so 5 into 27 plus 27, that is equal to 135. Okay, so the change in rate of descent required will be plus 135 feet per minute. The plus sign here denotes increase in rate of descent. So let's say your initial rate of descent here is 500 feet per minute. So you will increase that rate of descent to 600, at least 600 feet per minute by 100 feet more. Okay. Next. Aircraft is at flight level 350 and it has to descend to a new level of 80. Rate of descent is given, ground speed is given. What is the distance from the DME facility at which you should start your descent? Okay. So let's say this is your DME station and this is your aircraft. And you are currently at flight level 350, have to descend to a flight level 80. Okay, so this will be your rate of descent. So rate of descent is 2000 feet per minute. You have to calculate your horizontal ground distance from this DME station, how far you are located from that ground station distance. Speed, what is the speed of your aircraft? 275 knots. Speed is 75. Okay, now distance, you want to find distance. So distance, you can use speed distance time formula. Distance equals to speed into time. You already know the speed, 275 knots. Now the time taken to descend from 35,000 feet to 8,000 feet will be how much? So rate of descent equals to change in height divided by the time taken. So 2000 feet per minute equals to change in height. You are descending from 35,000 to 8,000. So 35, that is equal to 27,000 divided by the time taken. So time will be 27,000 divided by 2000. So time will be equal to 13 minutes 30 seconds. So approximately 13 minutes. Substitute this value in the distance speed time formula. 275 into 13 minutes divided by 60 hours. So 275 into 13 divided by 60 is 559.58 or approximately 60 nautical miles. Okay, so you are 60 miles away from this DME station. Next, aircraft is at flight level 390. It has to come down to flight level 70. Rate of descent 2500. Speed 290. What is the range? Again, similar question. So let's draw this. Here is your DME station. Okay, your aircraft is here. So this is your horizontal distance, which you have to find out. Okay, now your rate of descent is equal to 2500 feet per minute. The cruise speed or the descent speed of your aircraft is 290 knots. speed is 290 knots. Okay. Now, rate of descent equals to change in height divided by time. So 2500 feet per minute equals to change in height 25,000. Correction. You are descending from 39,000 to 7,000. So 39,000 minus 7,000 is 32,000, right? So 2,500 equals to 32,000 divided by time taken. So time equals to 32,000 divided by 2,500 is equal to 12 minutes 48 seconds. So approximately 13 minutes. Approximately 13 minutes. So distance will be equal to speed into time. Speed is 290 knots. Time is 13 minutes divided by 60 hours. So 290 into 13 divided by 60 is 62.8 or approximately 63 nautical miles. So your aircraft is 63 miles away from the DME station. What will be the rate of descent when flying down a 8% glide slope at a speed of 240 knots? So glide slope in terms of percentage equals to tan theta into 100. Okay. So 8% will be equal to tan theta into 100. So tan theta will be equal to 8 divided by 100, that is 0.08. So theta will be equal to, theta is nothing but your glide slope angle. So tan inverse 0.08. Tan inverse 0.08 is 4.5 degrees. 4.5 degrees. Okay. So let's say this is your runway and this is the horizontal distance. This is your glide slope. Okay. So this glide slope is inclined at an angle of 4.5 degrees. Now, your rate of descent equals to glide slope angle in degrees multiplied by the speed of aircraft in terms of feet per minute. So multiply speed in knots by 101.3 divided by 60 is equal to 4.5 degrees. Speed is 240 knots into 101.3 divided by 60. So 4.5 into 101.3 into 240 divided by 60 is 1823. Rate of descent is 1823 feet per minute. Aircraft is at flight level 350, wants to come down to flight level 110. 125 miles away from the facility. Ground speed is given. What is the rate of descent? Simple question. So, let's say this is your VOR DME station. Okay. Here is your aircraft. Next, you have to descend to VOR DME station. You are currently at flight level 350 and you want to come down to flight level 110. You are 125 nautical miles away. Okay, and your ground speed is 350 knots. Ground speed is 350 knots. So, rate of descent. Rate of descent equals to change in height divided by time taken. Right? So, the change in height is nothing but 35,000 minus 11,000. That is 24,000. Divided by time taken. So, the time taken to descend from 35,000 to 11,000. How will you find out time? Use this speed distance time formula. So time equals to distance divided by speed. So 125 miles divided by 350 knots, that is equal to 21 minutes. 21 minutes. Okay. So next, 24,000 divided by 21 is 1142.8. So approximately 1143 feet per minute. So select that option which is closest to this value. Next, true airspeed is given, course winds are given. You are going to descend from 22,000 to a level of 4,000. Distance 50 miles. What is rate of descent? Okay. So again, it's similar to the previous question. Rate of descent is nothing but what change in height divided by the time taken. So you're descending from 22,000 to a level of 4,000. So change in height will be 22,000 minus 4,000, that is 18,000 divided by time taken. So to find out time, you must know distance divided by speed. Distance is given in the question, 50 nautical miles. Ground speed is not given. We can calculate ground speed using CX3 and this information. So let's, okay. So true airspeed is 197, course 240, winds 180 at 30. Okay, so wind speed 30, wind direction 180, task 197, course 240. This gives ground speed equal to 180. Okay, ground speed equal to 180. So 50 divided by 180 is equal to 16 minutes. 16 minutes. So rate of descent, which is equal to feet per minute. So that is 18,000 feet per minute, that is 16 minutes. So 18,000 divided by 16 is 1125. 1125 feet per minute. Okay, next. By what amount must you change the rate of descent to maintain a 3-degree glide slope if you meet an increase in headwind of 14 knots? Okay, so the change in rate of descent required is equal to 5 into change in speed, change in ground speed. So 5 multiplied by change in speed. Now whenever there is an increase in headwind, the ground speed of your aircraft will decrease, right? So if headwind increases by 14 knots, ground speed will decrease by the same amount. It will decrease by 14 knots. So the change in speed will be minus 1/4. So 5 into 14 is 70 and minus 70. So minus here denotes that your rate of descent must be decreased. Okay, the rate of descent must be decreased by 70 feet per minute. And how will you achieve that? You will achieve that by adding adding some engine power. Okay, next, 88. What will be the rate of descent when flying down a 12% glide slope at a speed of 350 knots? So glide slope in terms of percentage equals to tan theta into 100. So 12% is equal to tan theta into 100. So tan theta will be equal to 12 divided by 100, 0.12. So theta, that is glide angle, is tan inverse 0.12, shift tan inverse 0.12, 6.8 degrees. Okay, so rate of descent will be equal to glide slope angle in terms of degrees multiplied by ground speed of your aircraft multiplied by 101.3 feet per minute divided by 60. So 6.8 degrees into 101.3, ground speed 350 into divided by 60. So 6.8 into 101.3 into 350 divided by 60 is 4043. Okay, 4043 feet per minute. That's your answer. So select the answer or the option which has a value which is closest to this one. Next. You are 95 miles from a VOR station. You have to descend from 33,000 to a level of 10,000. What should be your rate of descent? Its speed is 250 knots. Okay. So let's say this is your VOR station. Here is your aircraft. Okay. And you are 95 miles away from this VOR station. You are 95 nautical miles away from this VOR station. You have to descend from a level of 33,000 to 10,000. So flight level 330 to flight level 100. Speed is 250 knots. Speed is 50 knots. Now when you know speed, you know distance 95 miles. Time can be calculated using distance by speed. So 95 divided by 250, which is equal to 22 minutes. So rate of descent will be change in height divided by time. So 33,000 say 10,000 is 23,000 divided by time taken is 22 minutes. So 23,000 divided by 22 is 1045. Okay, 1045 feet per minute. Next, what is the rate of descent on a 12% glide slope with a speed of 320 knots? So glide slope in terms of percentage equals to tan theta into 100. So 12 percentage equals to tan theta into 100. So tan theta will be equal to 12 divided by 100, that is equal to 0.12. So theta will be equal to tan inverse 0.12. Shift tan inverse 0.12, 6.8 degrees. Rate of descent equals to glide slope angle into speed divided by 60. Make sure you multiply that speed in knots by 101.3 feet per minute. So 6.8 degree into 101.3 into 320 divided by 60. So 6.8, 101.3, 320 divided by 60. 3673.8. 3674 feet per minute. Okay, 3674. So we'll stop here. I hope you have understood all the 10 questions that I have answered in this video lecture. Let me know your feedback, any questions in the comment box. In the next video lecture, I will solve the last 10 remaining questions. So do watch that video lecture. See you.